Today I'm working on my 1972 Dodge Challenger. I've talked about this car in a previous video. This chassis has almost nothing except for maybe the front suspension and the rear axle. Aside from that, there's nothing on this car. There's no electrical, there's no brakes, there's no engine, there's no transmission, etc. So we're going to go ahead and start with the brake system since it seems to be the easiest thing to get going. The steering column is mounted onto the pedal assembly, so I went ahead and I picked up a set of pedals. There was a Mopar swap meet not too long ago and I found these sets of pedals. The only issue with these is that they are for a manual transmission car. There's the clutch, there's the brake. I still don't have an accelerator pedal, but that's okay. Those should be pretty easy to find. So I might actually convert this car to a manual. What do you guys think? But now that I have the pedal assembly, I should be able to get the steering column all lined up where it needs to be. As for the brakes, this is what I came up with. Since we're going to be going with either like a big cam NA motor or a turbocharged boosted motor, I need something that'll help me stop. And standard vacuum brakes don't seem to be an option for me unless I run an external vacuum pump, but that's just more weight, more space, and something else that can go wrong. So what I decided to do instead, I want to try running manual brakes, and not just standard OE manual brakes like on these old Mopars like this one. This is actually a kit online, and this uses a more modern master cylinder from like a Mopar of the 80s. It uses a bracket to go into the stock location where the booster should go, and then I also purchased a backing plate for it so that way it can support itself on the firewall. I talked to the gentleman at Dr. Diff, and this is the setup that he recommended to me, so this is what I ended up purchasing. It really wasn't that expensive, but I'm hoping that it actually does what it needs to do, because I really don't want to install the brakes, have everything in the engine all done, and then realize that my brakes aren't good enough and then I'm gonna have to redo everything all over anyway. So here's to hoping this is good enough, but I still don't know. As for how this gets mounted, it actually just uses the same holes that we would be using before, and it goes into its pretty much stock location, and I kind of like it. It doesn't take up a lot of room, and it should run. And leave it right there, and it should be able to stop the car pretty well, but like I said, that's yet to be seen. For the most part, at least it looks good. The way it sits, it's kind of out of the way, and we should be able to move on to the next thing. I'll probably go ahead and bolt that down now, but now that I've selected a master cylinder, we can start running the brake lines. As for the brake lines themselves, I mentioned that we don't have anything for this car, not for the front, not for the rear. So I picked up this universal kit from Jags. It has like a bunch of different fittings and stuff along with the hose. And although I do have a tubing bender, I don't have a flare tool, so I'm gonna have to go out and buy a flare tool. But I picked up the universal kit, and I also picked up this roll control line lock type thing, and we're gonna be installing that somewhere along here as well. What this thing is supposed to do is that since we're going to be planning on drag racing this car, we're going to want to use this to actually hold the front tires as you're doing the burnout so the car doesn't roll forward, and then once you want to roll forward, you can let go of the button and the car rolls forward. I've always wanted to install one of these on my truck and in my Charger. Never really got around to it. So now that I've got the entire brake system apart on this car, I think it's a perfect opportunity for something like this. This is a flare tool that most of us are pretty used to using, and in fact, this is the exact same tool that I've used pretty much all my life. I've always had problems with getting the flare like perfectly centered, or making sure that I don't flare too far, or making sure I put enough bevel on the brake line, or being careful and not allowing the line to slip out of the tool. A lot of reasons why this is probably not the ideal setup, especially when you're making so many bends on a vehicle, and some of those bends will eventually get a little difficult to get to if you eventually have a problem down the road. So in order to try to alleviate this, I've switched over to a different tool. Is this one offered by Jags? A couple other people manufacture this type of tool as well. This tool is a little bit more expensive than the guy we just talked about, but let me go ahead and show you what's involved. So I've already got the tool set up on a vise. You're going to need a vise or something stiff to bolt this thing down to, because you're going to be putting a lot of force through this handle that's right here. And basically how it works is that you got two sets of degree wheels. You've got a 37 degree wheel and you got a 45 degree, depending on what you're trying to do. 37 degree flares are basically for AN lines or copper lines. And then there's the 45 degree SAE flare used for SAE fittings, or you can use the 45 degree double flare for brake lines, and that's what we're going to be using. Since we're going to be using a 45 degree double flare, we're just going to grab the 45 degree wheel, slap it on there, and then we're going to get the appropriate dies, which are these guys right here, and then we're going to set it up to 45 degree 3/16. So 3/16 is the size of tube that we're going to use, and then 45 degree is going to be the angle of the flare. So we're going to drop these guys into here. Then you would go ahead and just lock this guy in, and you would put light pressure on this guy if you had a brake hose in here. The next step would be to just put the little dial on operation 0, and then you would zero out the hose up against the dies, and then you would turn it to operation 1, which would be this guy right here, operation 1 3/16. And then that would give it the first flare, and then if you were doing a double flare, you'd have to turn this into operation 2, which is this orange one, which is 3/16 as well. And then same thing, you just tug on the handle, close that up, and then once you finish that up, that'll give you your double flare. I went ahead and put one nut on this thing so it wouldn't fall down, but I think I've found a complication. Some of these fittings will slip right in, like for example this one, but the other one, for example this one, I believe it's a 9/16, this one won't. It'll go in about a thread, maybe a thread and a half, and it's a dead stop. It's not like it's caught up on anything. It's almost like if it's the wrong thread. So there's no way that the back one will be correct and the front one's not, because both of these that I've used are standard thread, and the ones that are in here, they're either standard thread or a metric thread. So what I actually have to do is I have to find metric nuts that'll fit onto this master cylinder to see if it's actually a metric thread or not. So I'm gonna have to run over to the parts store or check through my parts bin to see if I have a couple of the metric ones. Like I mentioned, this is a mopar style master cylinders, so if I check my mopars, I might have these correct fittings, but I might not, so I'll double check on that. The second complication is that this guy right here is not inverted flare like the other stuff is, and these fittings right here are inverted flares. But if you can check inside, there's no taper on the inside and there's no taper on top, which leads me to believe that this is not a taper fitting. This is going to be an NPT fitting. So I'm going to need to find myself an NPT fitting that'll fit the top and bottoms on one of these. Or if I want to go AN, then I can go like 1/8 inch NPT to -4 AN if I wanted to. Now that I've got all the correct fittings, I'm going to build out the brake system. In order to give you guys a clearer picture, I went ahead and I removed the brake master cylinder from the car, just so you guys have a close-up before I end up buttoning everything up. The front reservoir actually feeds the rear brakes, and the rear reservoir actually fits the front brakes. If you have a confusion of which one's which, you can go ahead and remove the caps, or if you have a reservoir that only has one big cap, and you can stick your finger in it if you can't see. But the smaller reservoir that's here is for the rear drum brakes, and if you have the larger reservoir, that's going to be the front disc brakes. So there's plenty of more room in this one than there is this one. Now if you end up switching to the rear disc brakes, you don't necessarily have to switch over to another reservoir. You just have to make sure that the reservoir that you have can feed enough fluid to the rear brakes. Continuing on to my line routing, we are using nickel copper rods, and these were my test pieces that I ended up making just to make sure that I was able to get the bends that I wanted. But these are functional lines, they just look a little bit sloppy. Like I mentioned before, this rear port is going to go to the front brakes, this front port is going to go to the rear brakes. If we flip this master cylinder upside down, you can see that on this proportion valve that I utilize, it has a letter and number R1 and F1. So F1 is going to go to the front, which it has, and R1 is going to go to the rear, which it has. The proportion valve that I have here is actually an adjustable proportion valve. I ended up picking this one up over at Jegs, and here's a part number for that guy right there. So now that I figured out the routing from the brake master cylinder to the proportioning valve, I need to figure out the routing from the proportioning valve to the front and rear brakes. So if you guys can check here, just like we had F1 and R1, we have two F0s. One's going to be for the left, one's going to be for the right, and the other one's going to be an R0, and that's going to be for the rear. The way you can tell, like if you didn't have the numbers or if the numbers happen to be erased, you can tell that these two are for the rear brakes because this is where the adjustment is for the brake line. The only thing that the adjustment does is that it opens and it closes the orifice inside of the proportioning valve to limit the amount of fluid going to the rear. It can't necessarily add pressure or add fluid, it can only slow it down. So if you have it in its maximum setting, then it's just fully open, it will get the same pressure that the front sees. If you close it halfway, then you're going to slow the rate that the fluid feeds the rears, but you're not changing the overall pressure of it. If you wanted to, you can use an off-the-shelf one that was made for your specific vehicle. For example, on the 72 Challenger, you can use a 72 Challenger proportioning valve and it should fit. The reason that I'm going to be switching it is because I'm going to be going through different combos, different axles, different tires, different brake systems. And so with an adjustable valve, you can readjust whenever you change something, whereas running a stock proportioning valve will only allow you to run front disc, rear drums out of a stock vehicle. With an adjustable one, you can do pretty much whatever you want. So now that I know that the two orifices pointed toward the front of the car are for the front wheels and the back one is for the rear wheels, we can go ahead and start installing this and routing those brake lines. So we are going to be starting this adventure from underneath the car. I've got the brake master cylinder up there, and as you can see, there's absolutely nothing under here relating to the brake system, not the hydraulic brake system, and nothing related to the e-brake except what's on the axles. We're going to be skipping over the e-brake stuff because that has nothing to do with what we're talking about today. The only thing that we're worried about on this side is the hydraulic system for the rear brake drums. So originally we had the OEM proportioning valve sitting right around here. And then from the proportioning valve, we had two lines, one for the front, one for the rear. And then they went in a bunch of loops and then they continued up toward the master. After those two lines came down and entered the proportioning valve, we had the same three lines exiting. One's for the front left, one's for the front right, and then only one of them is going back down toward the rear. So in order to clean things up, I want to go ahead and pull the lines directly from the proportioning valve that's up top. I'm going to try to make this as neat as possible, so we're going to put a couple bends in up there, come down. We might go ahead and make the couple of swirls like we're supposed to, and then have the rear line continue down, maybe around here, and then continue down this way, across this frame rail, through this access hole right here. But then from here we can go in a couple of different directions. I've seen people run their brake line across through their tunnel. That's not going to be an option for us because this tunnel is actually coming out. In a future episode, I'm going to be showing you guys why we're ripping out this tunnel. So the line will actually turn coming out of here, and then it'll turn again, and then somewhere on these we're going to fasten a couple of straps. Then the brake line continues on this way. There's going to be another strap. Then it's going to continue on back, and then from here I'm not actually sure where the brake line is supposed to go. There are a couple of access points up there for me to jump over and make a bunch of loops and then go around this leaf spring and then go up here, and that all seems like a big hassle, and there's a big reason why I don't want to run it down this way. The main reason is I'm planning to run side exit exhaust on this car, so if I have brake lines going across the rocker panel right here, that's going to be really close to the exhaust that I'm planning to put on this car. So I don't necessarily want to cook my rear brake lines. So a better place to run the brake lines will be to run across here down the middle of the floor pan. The only issue with doing things like that is that I want to run subframe connectors from here to the front of the car. And if I have brake lines here, they're going to get in the way of the subframe connectors. Lucky, the subframe connectors are not something that I'm going to be doing right now. But if I want to save myself a little bit of work in the future, I'm going to have to plan around that. So here's what I came up with. We're still going to keep the proportioning valve where I put it. We're still going to route that line coming down. We're still going to do a couple of loops so that way we can keep the stress off of the brake lines. From there, we're going to come down. We're going to wrap around here so that way I don't have to notch the body or do anything crazy over here. We're going to go around this lip right here. We're going to travel across this frame. We're going to go through this access point just like we talked about earlier. We're going to come out of the access point. We're going to go ahead and turn right here, and then we're going to turn again. We're going to fasten the brake line to some of these holes. Then from here, we're actually going to turn. And then once I turn here, you can see that there's an opening, a flat spot right here without any kind of bends leading to the back of the car. I'm going to try to line up with this rear frame rail somewhere around right here. We're going to go straight across to the back. We're going to follow this frame rail. I'm probably going to weld in a couple tabs. I'm not going to worry about the crease in the frame rail right now. We're just trying to get the brakes installed. We'll worry about this at a later date. So we're going to go around the parking brake right here, and then leading up to here, there are these couple holes. I'm assuming they were for the brake line. They could not be, but they might be. And then from here, it'll either go up on top and then point down, or we'll end up feeding the hard line right here into a bracket that we're going to weld onto the body. From there, we're going to run a soft line, either a rubber line or a braided line. We're going to run that to here where the breather is supposed to be. And then that breather is going to have a T. That T is going to feed the left and the right brakes. And we're going to be keeping the drums for right now. So from that T, the only thing we have to run are two hard lines. and we don't have to worry about rubber lines or anything like that. So now that we have a general game plan, let's go ahead and get to work. This is basically a master kit. It came with brake lines, it came with fittings, it came with clips, and it came with like the little tabs, the little welding tabs that you can weld into the body yourself, so that way you can get all of your hard points mounted up. It comes with standard steel brake line, which isn't as fancy as the nickel copper stuff that I used up in the front. But since we're going to be going a really long distance on the car, I don't mind going with the standard stuff in this particular application. Depending on how easy or difficult this is to install, I might consider using it for the front brakes as well, but that is yet to be seen. So let's go ahead and pull this out and start unwinding it. So I went ahead and started unwinding this brake line coil. We went ahead and ran it through the body right here, and then from here we took a straight shot all the way to the rear axle. From here, like I mentioned before, I don't actually know where we're going to stop, but it is going to be somewhere in this direction. So worst case scenario, I'm going to go ahead and leave a couple inches extra before I actually get around to this part right here. So I need to find a way to fasten this to the car so that way it doesn't move on me while I make the other bends. We can always come back and then finish this up later, so that's not a really big concern for me. My main concern is actually getting all of the bends in their proper locations. So I'm going to be starting in this halfway point and then working my way back. Whenever you guys are building something from scratch, you always want to keep in mind how you're going to be taking this apart when the time comes, because sure enough, even after you've got it all perfect and squared away, there's going to be some rhyme or reason why you're going to have to take it apart for something else. So that has to be done on the car before this was done. So in order to save yourself the headache, when you guys build something, build it so that it can be taken apart easily. So like I mentioned, there's going to be a steep turn right here, so that way we can put it up against this frame rail and then tie it to this part right here. And from there, it's going to turn back toward the middle of the floor. So you're going to have a big U shape right here on the brake line. So we're not going to be able to fit that through this access hole. So what I'm going to do is I'm actually going to design this brake line where I can go ahead and pull out the brake line this way, going back toward the car, instead of trying to go that way. So in order to do that, I'm going to be adding myself a connection somewhere around here at a site, so that way when it is time to take this apart, whether it's for paint or for undercoating or whatever, it can be easily disassembled. All right, fast forward a couple of minutes, I've introduced a couple of bends here. As you can see, I've made all the bends by hand. There's nothing too crazy, nothing too fancy. I'm not trying to make anything kind of show quality, at least not just yet. I do want to get all the bare bones of this car sorted out before we actually start putting some nice stuff in here. So for the first couple of bends, I had to adjust and redo some of them because I wasn't able to get them to stop hitting this access hole right here, but it looks like I pretty much got it down. I ended up grabbing one of the extra straps that I had, and I just ran a temporary one right here just to get a general idea of how it was going to sit. So we're going to have one here, and then we're going to probably run another one right there. If I want to kick this line out a little bit further that way, I could always shorten this corner a little bit, kick some of this out that way, and just start feeding the line out. Depending on how you bend it, you either shift the line this way or you shift the line that way. So you just have to keep in mind for when you make your changes. I went ahead and I started making the bend for over here. As you can see, now I have too much after I've made a couple other bends. I'm supposed to be somewhere right here in the middle, and now I'm far off to the left a little bit. So I've got to go back and redo some of this. Continuing on here on the back, I'm just going to hold it with my hand real quick. We're running the line across the bottom right here and then feeding into the frame rail just like I mentioned before. From here, it follows the same track as the frame rail, and then it feeds up to right there. If you guys recall, originally I had the line feeding all the way to like over here, but with all the bends and everything, it shrunk it down considerably, so I probably should have fed it out a little bit more. Having too much is a lot better than not having enough, so definitely messed up right there. I mean, it's not necessarily too late. I can unbend some of this, feed another foot or so out that way, and then try again. But that's why I went with the more inexpensive kit, because I knew I was going to run into these kinds of challenges. So right now I'm just trying to get it to work. We'll worry about the fancy stuff at a later date. As for the line coming from the proportion valve, I mentioned that we were going to take a hard line, twirl it a couple times, and then come down. Instead, I'm going to grab one of the steel braided brake lines that came with the Jegs kit, and I'm probably going to feed the line into a fitting that's going to connect up there. And then the line's going to come down this way and then back toward this frame rail on the bottom. I'm probably going to install some sort of bulkhead right here. So these are the bulkhead pieces that came in the kit. So we have the bulkhead tab that goes right here. Inside of that will go this bulkhead fitting, and this will go inverted flare, which is our hard line, to a -3, which is our braided brake line. And then we'll have a retainer clip that'll just kind of press in right here, and then hold everything in its place. So if we jump back underneath the car, I can give you guys a better idea of what we're looking at. So we have the bulkhead that we were talked about right here, and then I went ahead and I attached the steel braided brake line that comes with the kit. So from here, all I need to do is figure out where to cut the hard line and install the inverted flare fitting, and then that'll go to one side of this bulkhead. The other side of the bulkhead will feed the -3 brake line, which will then come up to right here, and then that one will end up feeding the rear brakes right around right there. The only thing I need to do is I need to go to my hydraulics shop and then pick up a couple of fittings. One is going to be an inverted flare to -3, and then the other one's going to be a -390 that's going to be female on the part that goes in the master cylinder, and then male on the part that will go right here on the steel braided brake line. So unfortunately, until I have those two pieces, I won't be able to continue the rear brakes. In the meantime, let's go ahead and take a look at the front. For the front brakes, we are going to be running into a very similar situation. We've got to come out through one of these ports. I'm probably going to use this one for the left. I'm probably going to use this one for the right. So since I already took off the wheel from the left side, let's go ahead and follow that one down. So we're going to come out this way. We got to go ahead and angle itself down. I'm thinking about running this line either below the frame rail or across the frame rail, and then coming out through the other side. Once I'm on the other side, I can cut across through the bottom, come up here, make a left right here, and then come back down, which I'm almost positive that that's how the factory ended up doing their system. And then from here, I can go ahead and run the braided line from here out to whatever calipers we're going to use right here. The only caveat is that I'm going to have to twirl the brake line maybe 2 times before I head down, but we already talked about that, so that shouldn't be a big deal. In order to accomplish this, I'm going to be switching over from the JEGS hard line, and we're going to be switching over to nickel copper or NiCop brake line. So in order to make the brake line coils, you can either use a hole saw like I'm doing, or I've also done it with a full soda can. Really, you can use anything as long as it's round and it's stiff. I'm going to be using electrical wire to demonstrate because I only have one hand for this. But basically all you're going to do is you're going to just wrap it around the soda can, or you're going to wrap it around the drill bit, as many coils as you need, and you're going to clock it in the right direction. If it needs to both face the same way or opposite directions, or whatever you need it to do. Doing it this way prevents you from putting a kink in the lines and also makes it look nice and uniform. Since, like I mentioned, nickel copper brake line is a lot easier to bend and easier to flare than the standard brake line, I feel like this is a really good place for it. So let's go ahead and grab the roll that I bought and see how well it fits. So this is what it looks like on the driver's side wheel. We have that brake line that we talked about going down, then it goes under the frame, comes back around this way, then comes back up. Originally I had another hard line leaving the roll control solenoid. Then that line used to exit, go this way, and then it comes down, and then it used to hook up to the stock brake line that we have here, and then that used to go to a stock caliper. Well, since then, I've actually upgraded to 13-inch rotors, and so then I'll need a set of calipers to match this, and the stock lines that I was going to run aren't going to match anymore. So what I've done is I've actually acquired a different set of calipers that we'll show you guys in a later video, because I have to make a custom bracket, and how we're going to connect that to the roll solenoids by one of those brake lines that we talked about earlier, and that's going to go to the back of the caliper. It's going to hook up like this. I've already verified that when the caliper's on and I'm full lock on one way, I'm fine, and then I'm full lock on the other way and I'm also fine, and so I'm not going to have any tire interference. But if it ever does become an issue, I can always add a hard line here, move this line somewhere over here, and then try it again. And then I can just keep playing with it until I find a good spot for it. This is the exact same way that I'm going to be doing the other side, so I'm going to jump on that and finish that side up real quick. For the front right brakes, I ended up doing the same thing or a similar thing as the left front brakes. I went ahead and I pulled out the 3/16 inverted flare fitting into a 2-row coil, and then I made a 90-degree bend on that. After the bend, I followed pretty much the OEM brake line routing all the way into the frame rail that's right here, where I made another 90, and then I'm going to add a clip or some sort of bracket that'll hold the brake line probably somewhere around that hole or where that other clip is. And then it continued forward, and then it wrapped around this frame rail, and then it came back up on this side where it made a turn. And then right here where the line terminates, I just need to fit another roll control solenoid so that way it matches the left front. So with the 2 roll control solenoids, I should be able to lock out the front wheels in order to do an easy burnout in the staging lanes when we go drag racing. From there, I'm going to continue it on as the other side. I'm going to go out through the top, wrap around here, come right back down, and then I'm going to go into the factory bracket that's right here, and then into a soft line. That'll go from here to the caliper. Some of you guys might be wondering why I'm choosing to install 2 roll control solenoids when typically people only have 1, and they'll usually have it up by the master cylinder. Well, there's a couple of reasons. Number one, my proportioning valve, as you guys can see, it's really close to the brake master cylinder. So in order to add this to the brake system, I'd have to interrupt the line that goes from the master cylinder down to the proportioning valve. So I'd have one going down to wherever the roll control solenoid is, and then I'd have another one coming back up from the roll control solenoid back into the proportioning valve. Typically, that's not a problem for most people. You just run a line to here, run a line back, and you're done. The problem for me is that I think it'll look a little ugly with this thing in the engine bay, even if I try to hide it behind some stuff. I'm trying to make the engine bay as open and clean as possible. So in order to do that, I've got to move this thing out of the engine bay. Well, since the front brake lines are divided at the proportioning valve, one for each side, now I've also got to include one of these guys, one for each side as well, in order to make this work. In a standard application, you really don't want to bother with more than one, so this is all personal preference. For the last fitting on the proportioning valve, there were a couple options. The first one was to introduce another coil, just like I did for the other two, and it would probably end up down there somewhere, which is still definitely possible. I can definitely run a hard line going down from the master cylinder and then feeding to the back, but I feel like it's just too many coils. It would just look really busy right there. I kind of want something a little bit more streamlined, so then I figured that if I can get a 90-degree fitting off of here, then I should be able to run this guy like a braided line down here, either in between the column or through the outside of the column. So to accomplish that, I purchased a few things. The first one was it's a 3/16 inverted flare to a -3 JIC or AN. And this fitting is supposed to go into the proportioning valve right there, and then this fitting is the one that leads into the rear brakes. And then from there, I was supposed to put this 90 on there, and these 90s were actually pretty expensive, and although these 90s were pretty expensive, they're not actually going to work, because although it fits right here when I intended it to fit, because of the height of the inverted flare fitting, we are now going to be running some sort of interference between this and the steering shaft, so this is not going to work after all. So what I can do, instead of running the braided line straight down like I was planning to, because it was going to interfere with the shaft, I can go ahead and turn this fitting and then run the line a little bit closer to the frame on this side, and then move the tip of the line somewhere along this frame rail right around right there. And then I can weld in the bracket to hold this line onto the frame, and then hopefully it'll keep it away from the steering shaft. The other option is to actually run the line straight across and then twirl the line around here and then end up in the same place that we were going to the other way. The only problem with that, and the only reason I don't like it, is that I feel like the line's going to be a little too stressed. Instead of having almost a straight C shape, it's going to have more of an S bend, and I feel like that's going to stress out the braided line a little bit more. So what I'm going to do is I'm actually going to raise the car up a little bit and get a better shot from underneath and see what works out the best. So I think this is what I'm going to go with. I'm going to go with the 90-degree fitting and then the straight line right off of here. I did try looking for an inverted flare to male JIC AN fitting, but the problem is that you won't get the benefit of the swivel. So unless the fitting is clocked exactly the way you need it to, chances are it's going to be pointed the wrong way and you won't be able to get a good seal on the inverted flare fitting. So we're going to go with the 2-piece fitting right here. What I like most about this is that you can set up the braided line so that it can naturally get away from the steering shaft. So I've set it up right here more or less where I'm thinking about having it installed, and then I could always tweak it one way or another depending on how I want it to go. But look at the clearance that I have around the steering shaft. Even in the most extreme cases where the fitting is one way or the other, I still don't get close enough to the steering shaft to the point where it can be a problem. So it looks like that's what we're going to go with. I'm going to go ahead and install this bracket right here. Once I have the tab tacked up in place, I'm going to go ahead and cut the metal line, and then the metal line is going to get flared out, so that way I can install the fitting right onto the tab, and then I'll be pretty much done with this part of the brake system. So this is what we're doing for the rear brake lines. As you can see, I already have a couple of hard lines running down across the back of the axle, but these brake lines actually belong to a Mopar 8 1/4 that we had sitting in the backyard, and with a little bit of stretching here and there, I was able to make the lines fit. So overall, I think they're all going to work just fine. The only issue is that these lines come with the T right here in the middle where the brake line feeds in from the center. I cannot seem to be able to get a factory brake line that works on this. I think it's a 7/16 by 20 inverted flare fitting that goes in here, so I could order one online maybe and then make a brake line out of that, but I think there's an easier solution. This is a brake line for a 1973 Dodge Charger, actually the same 1973 Dodge Charger that I've been working on, but this line has a built-in T and I don't have to worry about trying to feed it in there, so this is all one piece. What I'm going to do is I'm going to take the lines off of this junction block and then I'm going to feed them into this built-in junction block and then run this bolt in this hole right here, and then the rubber line's going to go ahead and run out to the chassis somewhere where I'm going to weld the tab and then be able to line up this hard line to that. So I'm going to get started on that swap and see how easy it goes. After a little penetrating spray and a little bit of elbow grease, I was able to get these fittings off the old T and then secure it back on the new T. I used the same bolt to put this thing back on, and now the rubber line is going to match up somewhere around right here with the new bracket that I'm going to weld on. So let's go ahead and do that right now. So this is where I'm thinking about welding the tab. There's already a hole here for something else. I'm going to want to close that up anyway, so if I just weld it right over that hole that's right here, it should give me a pretty clean spot and it should block that hole that's there. So I'll be able to kill two birds with one stone. I just tacked the bracket onto the frame rail, and now if I just lay this over through here, this is where the brake line's going to be. So you have to consider that the axle is going to come up whenever the car is back onto the floor. So you want to set it up so that when the axle comes up for ride height, the line doesn't bind itself. So now that I know that the position of this tab is good, I'm going to go ahead and finish welding up the bracket, and then I'm going to start figuring things out for the last brake fitting. Rear brake line is finally done. It starts up there, goes down the braided hose, goes into this bracket right here, continues through this hole right here, then turns around, goes down, goes through one, goes through another one, goes through up here, rides up along the rear frame rail, goes through here, goes around this corner, and then into this bracket right there where it feeds into the rear axle. From the rear axle, it goes into the T, then it feeds the left side and then the right side, and then we're all done. Well, that pretty much covers everything. As you can see, this is the finished product, and I've got plenty of clearance all around the brake system, and I'm pretty happy with the way it turned out. So hopefully you're going to be able to build out your own brake system when the time comes, and as you can see, it's not as hard as people make it out to be. So I will see you guys all in the next one. Night Wrencher signing out.